Yeah, good evening, ladies and gentlemen. Yeah, you are welcome to ninth class. Okay, tonight we'll be looking at problems on standard Laplace transform. As long as you understand what we have done so far, the properties, because we'll be making use of the properties, Laplace transform properties, to solve this type of problem. So let's proceed. Right solution, right? A Laplace of 1 plus 2t minus 1 all over 3 t raised to the power of 4. Whenever you come across questions of this one, I'm going to open your eyes how you are going to tackle it. Is that clear? Are you following? Is that clear? Okay. The camera is off. It's on. Yeah. Okay. So please try and wake others. Try and inform them. So now, what you need to do here is we have to use this Laplace transform to multiply out the brackets. So this is how it will be. Laplace of 1. And what we have here, plus Laplace of 2t minus Laplace of 1 all over 3 t raised to the power 4, right? So we can still rewrite it in this form. Laplace of 1 minus the coefficient of t here is 2, right? So 2 Laplace of t, then minus the coefficient of t raised to the power 4 is 1 all over 3. 1 all over 3 Laplace of t raised to the power of 4. Do you agree with me? So I'm going to break it one after the other. It's not difficult. Life of mathematics is always beautiful with Mr. Osi. It's okay. So as you can see, I don't know whether you don't understand what I did just now. Any question, please? Do you have any question? Yes or no? No question? So it means we can progress, right? It's okay. So let's progress. Let us progress. JJ, you are welcome. It's okay. I want us to go back to the properties that we did. Laplace of 1 we're going to give us 1 all over s. Two of us. How? Look at it. Look at it. I want to show you something. We know, or you know, that Laplace of f of t is equals to integral 0 to what? Infinity exponential minus f of t dt, right? It's okay. Yeah, you agree with me, right? I want to prove, I want to tell you. So if now you have been given Laplace of 1, it means this is the function, two of us. So our f of t is what? 1. So here we are going to have Laplace of f of t is equals to integral 0 to what? Infinity exponential minus st times what? 1 dt. So this is the same thing as what? Integral, true or false? Because 1 times this is 1 times dt, then 1 times exponential minus st is exponential minus st. So 0 to infinity exponential minus what? St dt, right? Yeah. So by the time we integrate this function, we are going to have minus exponential minus st all over s at what? 0 to what? Infinity. Then this will going to give us subtract the lower limit from the upper limit. So this is minus exponential. Anywhere you see t, you write infinity, right? All over s. Then minus the lower limit, minus open bracket minus exponential minus s 0 all over s. True or false? Whole of this will be what? 0. Sorry. Whole of this will be 0. True or false? Then minus times minus is what? Plus. So this is equals to plus. Then minus s times 0, 0. So exponential 0 all over what? S, which is equals to anything raised to power 0 is what? 1 all over what? S. So can you see now? Can you see now? So this is, you are going to make use of these properties to solve Laplace transform questions of this one. Is that clear? Take notes. Are you following? Take notes. Do you agree with me? Okay. So if you can see what I am saying, as simple as ABC. So let's clean this. Let us clean this. At least I've shown you how it works. True or false? So all these ones, you are going to do it in your rough work. So after doing it, getting the this is just substitute. So now we were able to obtain Laplace of what? 1 will give us what? 1 all over s. Then here we have 2 here. Here is Laplace of t. True or false? So let's look at it together. Laplace of t. Laplace of t is equals to integral 0 to what? Infinity exponential minus st. I don't want to cram it. Is that clear? That is why I'm doing this. So our f of t here will be what? T times t, right? Yeah, times t dt. Is that clear? So when you have functions like this, you don't need a prophet to tell you. It means you are going to use what? Integration by parts. True or false? Yeah, so we use by parts. U dv equals to uv minus integral v du. I don't want you to cram. That is why I'm taking this long process. Is that clear? So that you always remember to go about it. So we now say let u be equals to t and the v be equals to what? Exponential minus st dt. Right? True or false? I think we did something like this. Please, I want you guys to like. I want you guys to like. I think we did something like this. Yeah. We did something like this. Okay. So, if you can see what I'm saying, what we need to do, we have to differentiate this. The u all over the t will going to give us 1. Then the u will now be dt. Like I used to multiply 1 dt. Then integrate this. When we integrate, we'll have v equals to, because if we integrate v, integrate this, we are going to have minus exponential minus st all over s, right? It's okay. So let's substitute in. When we substitute in, this is what we are going to have. It means integral 0 to infinity exponential minus st t dt, right? It will now be equals to ordinary u is t, then ordinary v is minus, so we just multiply it like this, minus exponential minus st all over s at 0 to what? Infinity. So you can now see that everywhere will be 0. Sorry. So here now the ordinary v is minus exponential minus st all over what? S times du, the t, right? 0 to infinity. So whole of this will be 0. No, it cannot be 0. This one will be 0 minus, it means we are going to have 1 all over s, true or false. The minus times minus plus, when we integrate this, we are going to have a minus exponential minus st all over s times this s, that is s squared, right, at 0 to infinity. True or false? True or false? It's true, right? Please, I want you guys to like. Oh, it's not showing. Sorry about it. Are you seeing now? Can you see the right hand side? Please, I want you guys to like. It's okay. So, far so good. So here will now be 1 all over s plus times minus. Let us forget about it first. When we substitute in what is it called? Infinity here will be 0, then minus this. It means we are going to have plus 1 all over what? S squared. True or false? True or false? It's true, right? Yeah, it's true. So it means this is what we are supposed to have. 1 all over s plus 1 all over s squared. Isn't it? It is. But mind you, we have 2 here, right? So 2 open bracket this. When you look at it, true or false? We have 2 here. Right? Okay. So then here, 1 all over 3, then consider this. I want us to note that, Okay, let's write it out. it means Laplace of 1 is equals 1 all over s. Then Laplace of t gives us what? Gives us 2 all over 1 all over s plus 1 all over s squared. Right? Do you agree with me? Oh, for the sake of Malians, I should break it down. Japhet, John, I think there is no Malians here. It's okay. I will still break it down. No problem. It's okay. So far, so good. So then, Laplace of t raised to the power of what? 4, right? I think we did something like this, that we consider it to be Laplace of t raised to the power what? N, right? And this will automatically give us n factorial all over what? S raised to the power n plus 1. True or false? Yeah, when you go back to our first video, I think we did something like this. So if you come across something like this, you don't need a prophet to tell you. It means Laplace of t raised to the power 4. Now this is your n. 4 is your n, so 4 factorial all over what? S raised to the power of 4 plus 1. Isn't it? So which is equals to, when we say 4 factorial, 4 factorial means 4 times 3 times 2 times 1. Is that clear? Are you following? Huh? You understand? Yes or no? But mind you, we have 1 all over 3 here. True or false? So here will now be 1 all over 3, open brackets. 4 factorial is 4 times 3, 12, times 2, 24, times 1, 24. 24 all over s raised to the power of 4 plus 1 is raised to the power 5. S raised to the power 5. So this is what we are supposed to have. So if you can see what I am saying, hope you understand what we just did here. So take note of all these things. So you can now see that what we have been doing, we'll go back and make use of it. So here, I don't want you guys to cram all this and say Laplace of this is 1 all over. You know, it will not help you. Is that clear? So here will now be 1 all over what? S minus 2 open brackets 1 all over s plus 1 all over s squared, right? Close bracket minus 1 all over 3 open bracket what? 24 all over what? S raised to the power of 5. Amen? True or false? Look at the board. Oh, I think, yeah, we made a mistake. Sorry. There's a mistake here. there's a mistake here. Please, let's take it all over again. Laplace of t equals to integral 0 to what? Infinity exponential minus st t dt, right? Here we are going to use by part, right? Listen, we made a mistake here. None of you corrected me. So if we use by parts, u dv is equal to uv minus integral v du. Then let u be equals to t. Then the u all over the t is 1. Then our the u will be what? The t, right? Then let the v be equals to what? Exponential minus st dt. Yeah, I made a mistake. St dt here supposed to be here, will vanish. Supposed to run all over x raised to power 2. I want to prove that. So when you integrate v equals to minus exponential minus st all over s, two of us. So let's substitute n. So here we are going to have ordinary u is t, but ordinary v is minus, so minus t exponential minus st all over s at 0 to what? All of this will be 0, yeah, because of this t. Because if you substitute in this minus 0, yeah, everything will be 0. So minus integral 0 to what? Infinity minus exponential minus st all over s du is the t, right? The t. Can you see now? If you substitute in infinity, all of this will be 0. If you substitute in 0, because of this t, everything here will be 0. So if you can see what I am saying, here we are going to have a plus, right? This time this plus. But when we integrate, we are going to have minus exponential minus st all over s dot s, two of us, at 0 to infinity. So everything, when you substitute, this is what you are supposed to have. 1 all over, yeah. Do you agree with me, please? Sorry for that error. That is mathematics for you. So it means Laplace of t, Laplace of t will give us 1 all over s squared. So far so good. So far so good. So let's proceed. Let's proceed. Let me write it again here. Yeah. So here will be what? 1 all over s minus Laplace of we're going to give us 1 all over s squared, then minus 1 all over 3 open bracket. This will going to give us what? 4 factorial, right? Which is what? 24 all over s raised to the power of what? 5. True or false? So this is equals to 1 all over s minus multiply 2 all over s squared minus 3 to 8 is 1, 3 to this 8, right? So 8 all over s raised to the power of 5. This is the final answer. Any question before we proceed further to solve more problems? Do you have any question? No question? If there is no question, we can now proceed further to solve more problems. Okay, so let's look at another problem here. Another problem. We have more problems. Okay. Yeah. As simple as ABC. Laplace, evaluate Laplace of 5 exponential 2t, then minus 3 exponential minus t, right? I think this is simple as ABC. Is that clear? So it's the same approach. Is that clear? The same approach. Here will be Laplace of 5 exponential 2t, then minus what? Minus 3 exponential minus t, right? So we now multiply 5 Laplace of what? Exponential 2t, then minus 3 Laplace of exponential minus t, right? Do you agree with me? So let's try and find this and this. Mind you, 5 and 3 will be held constant. So if we have Laplace, we want to find Laplace of exponential 2t, amen, then this is equals to integral 0 to what? Infinity exponential minus st times what? Exponential 2t dt, right? True or false? Then we apply indices here. While we apply indices, we are going to have integral 0 to infinity exponential minus st plus 2t dt. Did I commit any crime? Look at the board. Is there any question? Please. Any question? Yes or no? No question? Yeah, we can proceed. Okay. Yeah. So let's proceed. Let us proceed. So far, so good. This is the same thing as integral 0 to what? Infinity exponential what is common? Minus t. Factor it out, minus open bracket s minus 2 dt dt, right? So when you integrate this we are going to have minus exponential minus open bracket s minus 2 t all over s minus 2 at 0 to infinity, right? So subtract the lower from the upper limit. So here we are going to have what? 1 all over s minus 2. Yeah, that is for here. Then let's consider this. But mind you, S is what? We have 5 here, right? Take note. Then let's consider Laplace of exponential minus t. This will be equals to integral 0 to infinity, then exponential minus st dot exponential minus t dt. Then this is the same thing as what? Integral 0 to infinity exponential what is just minus st minus t dt. True or false? Look at the board. True or false? Amen? Amen. It's okay. So if you agree with me, you don't need a prophet to tell you, JJ, thank you very much. You are very active. God bless you. I can see you from here. It's okay. So here, now this is equals to exponential 0 to infinity, then integral 0 to infinity minus open bracket s plus what? 1, right? Factor t, then the t. Now when you integrate this, we are going to have what? Minus open bracket minus exponential minus open bracket s plus 1 t at 0 to infinity. Then this will going to give us, when you substitute in 0 minus plus, all over s plus 1, yeah. So here will be 1 all over s plus 1. True or false? True or false? It's true. This will give us 1 all over s plus 1. True or false? True. Okay. So with what we have just done now, you see that it is not difficult. Let me clean this, then we begin to substitute. Right? You see that it is not difficult. So if you know your properties, so here gives us this, so 5 times open bracket 1 all over s minus 2, then minus, here is 3 times open bracket 1 all over s plus 1, right? Then this is equals to, amen, 5 times 1 is 5 all over s minus 2 minus 3 times 1, 3 all over s plus 1. Can bracket this one. So this is the answer. This is the answer. Yeah. But if you want to take the LCM, no problem. You want to take the LCM, as simple as ABC. This to multiply them, they will multiply each other, right? So 5 open bracket s plus 1 minus 3 open bracket s minus 2 all over s minus times s plus 1, right? So if you can see what I am saying, 5 times s is 5s, 5 times 1 plus 5, minus 3 times s minus 3s, minus 3 times minus 2 plus 6, all over, open this bracket, s times s squared, s times 1 plus s, minus 2 times s minus 2s, minus 2 times plus 1 minus 2. True or false? So this is going to give us, when we collect like times 5s minus 3s, we are going to have 2s plus 5 plus 6, 11, right? All over, here we are going to have s minus 2s minus s, right? So here we will have s squared minus s minus 2. Open, right? Yeah. So this will be the final answer. Any question? Is there any question? Can we proceed? Let's proceed further to consider more examples. Let us proceed further to consider more examples. Glory, no, you are just coming. Okay, let's proceed. Let us proceed to consider more examples. Yeah. Amen. Okay. Yeah. Here we are going to find the Laplace transform of, we have beautiful questions here, but by the time we solve all these questions, it will help you to solve some of the past questions, right? Okay, let's look at it together. So find the Laplace transform of, another example, find the Laplace transform of 6 sine 3t minus 4 cos 5t. As simple as ABC. Two of us. I want everyone to look at the board. Everybody. Look at the board very well. Look, ma'am, I know you are just coming. Those who are regular, JJ. I can never forget JJ, even if I'm sleeping. He has been faithful here. It's okay. Let's proceed to consider this. 6 sine 3t minus 4 cos 5t. Yeah. I want us to remember something. You know, the properties, one of the properties, if we have sine 80, it means that this is the same thing as your hyperbolic functions. This is the same thing as what? Exponential what? I80, right? Minus exponential minus I80 all over 2, right? True or false? True or false? Am I right? Sorry, all over 2i. Am I right? Yes. So if now we have sine 3t, is the same thing as exponential I3 or 3it minus exponential minus 3it all over what? 2I. Am I communicating? Look at the board. True or false? Abdurrahman Muhammad Awal. I know you are just coming. True or false? It is true, right? True or false? Japhet. Okay, so if you agree with me, it means instead of this, then what about this? This will now be cos 5t will now be what? Exponential 5it plus exponential minus 5it all over 2I. True or false? So take note of this. Is that clear? So if you agree with me, this is simple as ABC. So if you understand what we're about to do, it means this is equals to 6 open brackets exponential what? 3it minus exponential minus 3it all over 2I, then close brackets, minus 4 open bracket exponential what? 5it plus exponential minus 5it all over 2I, close the bracket. True or false? So we have to consider one after what? The other. So if we are to consider one after the other, it means we are going to have this is how we are going to have it. 6 Laplace of equals to exponential 3it minus exponential minus 3it all over 2I, then minus 4 Laplace of exponential 5it plus exponential minus 5it all over what? 2I. True or false? True or false? True. Right? It's true. Okay. So far, so good. So if you agree with me, or if you can see what I am saying, you don't need a prophet to tell you that Laplace of, let's consider this one after the other, exponential 3it minus exponential minus 3it all over 2I is equals to integral 0 to infinity, right? 0 to infinity exponential minus st dot times exponential what? 3it minus exponential minus 3it all over 2I dt, right? So this will going to give us, let's take one after the other, integral 0 to infinity. This will be what? Exponential minus st plus 3it, right, all over 2I, then dt minus integral 0 to infinity multiply exponential minus st plus times minus 3it all over 2I dt, right? True or false? So this is equals to integral 0 to infinity exponential minus open bracket s minus 3I t dt. We can factor out 1 all over 2I, right? Then the same thing minus 1 all over 2I, factor it out, integral 0 to infinity exponential minus s minus plus 3I t dt. True or false? True, right? Okay, yeah. So if you can see what I am saying, you don't need a prophet to tell you. This is equals to 1 all over 2I, open brackets, amen. Integrate this, we are going to have minus exponential, open bracket, minus s minus 3I t all over what? S minus 3I at 0 to what? Infinity. Okay, let's do it this way. Since 1 all over 2I is common, let us give them a big bracket so that we'll not be repeating 1 all over 2I. So open bracket, integrate minus exponential minus open bracket s plus 3it at 0 to infinity, right? Then all over what? S plus 3I. Any question? Is there any question? Take it again. Glory. Where do you want me to take again? Where? Glory. Glory, where? Where do you want me to take again? It's okay. Any question, just write it in your notes. Then ask me in class. We'll look at it together. Is that clear? Any question at all, don't forget, write it inside the notes. Then remind me in class. It's okay. So far so good. Let's proceed. Here will be plus 1 all over 2I, open bracket, right? So let's substitute 0. Then here will be what? Plus 1 all over s minus 3I, right? Here to 0. Here will be 0 minus. Then 1 all over plus 3. And this minus 1 all over 3 plus 1 all over plus 3I, sorry. Yeah, so we take LCM, 1 all over 2I, open brackets. When we take the LCM, we are going to have cross multiply, right? S plus 3i minus s plus 3i. I know very well that some of you are blind mathematically. So this is this is going to give us this times this x squared times this plus 3si minus 3i times s minus 3si, then minus 3i times plus 3i, we are going to have, we are supposed to have minus 9i squared. But I squared is minus 1. So use this minus to multiply minus 9 times minus 9. We are going to have plus 9, right? Yeah. So far so good. So here you don't need the prophet to tell this and this will go. By the time you add this, this is equals to 1 all over 2i, open brackets. Here will be 6i all over this and this will cancel to give us s squared plus, 9 is the same thing as 3 raised to the power 2, right? Plus 3 raised to the power 2. Then 2i to 6i is 3, right? So here will be what? 3 all over s squared plus 3. But mind you, don't forget, we have 6 here. So any question, ask your question. In fact, just copy your question in your notes. Copy the question in your notes inside. Is that clear? Copy the question in your notes so that in class you can ask them or take it all over again. It's okay. So far so good. So here sine 3t will give us 3 all over s squared plus 3 squared. So let's consider this. Let's consider this. Which one? Yes, let's consider this. Okay. So if you can see what I am saying, you don't need a prophet to tell you. Amen. Yeah. You don't need a prophet to tell you. See, let me just open your eyes here. Look at the board, please. Here, we have 3it minus exponential minus 3it all over 2i. It means here we are going to consider exponential 5it plus what? Exponential minus 5it all over what? 2i. So if this can give us 3 all over s squared plus 3x, it means here we are going to have 5 all over s squared plus minus 5 squared. That is what we are supposed to have. Yes, it's going to be plus. That is what we are going to have. So of course, so I want you to do the same thing the way we did this one. Okay, let's do it together for the sake of manners. Let's do it together. So here now here will now be exponential 5it plus exponential minus 5it all over 2I, right? So this is equals to integral 0 to what? Infinity exponential minus st dot open brackets, right? Exponential 5it plus exponential minus 5it all over 2I dt. So let's break it down. In an integral 0 to infinity, this times this will going to give us exponential minus st plus 5it all over 2I dt. True or false? Then this times this plus integral 0 to infinity, we are going to have exponential minus st minus, we are applying indices here, all over 2I dt. True or false? It's true. So here will be equals to 1 all over 2I integral 0 to infinity exponential minus open bracket what? S minus 5I dt. True or false? Then plus the same thing applicable here, okay? The same thing applicable 1 all over 2I integral 0 to infinity exponential minus open bracket s plus 5I, then t here t dt, right? Okay, yeah. So this will be equals to, let's do this. Since 1 all over 2I is what? Common, we can factor it out. 1 all over 2I. Come on, let us give it a big bracket. So here will be minus exponential. When we integrate this, minus open bracket s minus 5it all over s minus 5I. Then at what? 0 to infinity. Then plus open brackets minus exponential minus open bracket s plus 5it all over what? S plus 5I at 0 to infinity, right? Yeah. So if you can see what I am saying, this will now be 1 all over 2I open brackets plus, that is 1 all over s minus 5I. Then here, yes, plus 1 all over s plus 5I. Then at the end of the day, if you take the LCM of this, at the end of the day, this is what you are going to have, because you are going to, here will be, the numerator will be 10. At the end of the day, 10I. So 2I to 10I will be 5. So I want you to, on your own, do this the way I did the previous one. So this is what you are going to have. 5 all over s squared plus 25. And this is the same thing as 5 all over s squared plus 5 squared. True or false? It's the same thing. So far, so good. So here, let me take it up. So here will now be equals to 6, open bracket, Laplace of this gives us what? 3 all over s square plus 3 raised to power 2. Then, what do we have here? Minus 4, open bracket, Laplace of this gives us 5 all over what? S square plus 5 raised to power 2. Excuse me. Then this is equal to 6 times 3, 18 all over s square plus 3 raised to power 2. Then minus 4 times 5, 20 all over s square plus 5 raised to power 2. Then if you want to take the LCM of this, is it necessary? It is not. So this is how you are going to evaluate this type of question. Is that clear? This is how you are going to evaluate it. So far, so good. So I'm going to give you assignments. I will collect it on Monday. So I want you to write this down. It's very important. Very, very important. Okay. Yeah. Take note of this. This assignment determine the Laplace transform. Laplace transform of I sine square t I cos square 3t. This is assignment. Okay? So, gentlemen and ladies, thank you for your time. I love you guys. Have a wonderful bed rest. See you next week, Wednesday. Love you guys. Bye. Yeah, don't forget to share. Thank you. Thank you, Ahmad. So, write this assignment down. Monday, collecting it on Monday.